Question 16. A, B, C, D are points on the circumference of a circle, centre O. Angle BAD equals 112 degrees and angle DCO equals 33 degrees. Show that y equals 35. Give reasons for each stage of your working. So this one is a circle theorems question. So the first circle theorem that you must know is that here, this angle and this angle should add up to get 180, because opposite angles of a cyclic quadrilateral add up to 180. Okay, so cyclic quadrilateral is a quadrilateral inside a circle. So we need to work out that. So we can actually work out what this angle here is. So we would write, let's give this a letter X. Okay, so X would equal 180 minus 112. And now if you want to find out X, you would have to minus 33 as well. So you would get 35. Now that's not the final answer. So you need to give reasons for each stage you're working out. Opposite angles in a cyclic quadrilateral, opposite angles in a cyclic quadrilateral add up to 180 degrees. Then next step is that we know that since this O is the center and there are two lines here. There are two lines. This line and this line. Meaning they are the radius because it's touching the circumference. Therefore, this triangle here is an isosceles triangle. So, since OC equals OB, which is the radius, triangle OBC is isosceles. Therefore, y also equals 35 degrees. Now B, work out the angle Z. Give reasons for your answer. So here I need to work out what Z is. So I have got y is 35, this is 35 as well. Now if I know this is 35 and this is 35, I know that these three angles should add up to 180. So I would say that angle BOC equals 180 minus basically 70, which is 110. That's the reason being is that angles in a triangle add up to 180 degrees. Now once I know that this would be 110, I need to know the circle theorem of this. That angle at the center of a circle is twice the angle at the circumference. So I know that this is double this. So I would say that Z would equal 55 because angle at the center is double the angle at the circumference. Question 17. Write x squared plus 8x plus 3 in the form of x plus a squared minus b. So that form here is what we call completing the square. So the way to do that, okay, x squared plus 8x plus 3 is to first find a quadratic expansion that matches up with x squared plus 8x. Now to do that, we will halve the coefficient of this x, which is 4. So I'll do x plus 4 squared. Now if you work out x plus 4 squared, you'll get x squared plus 8x plus 16. Now I don't want 16, I want 3. So what do I have to minus? I have to minus 13. So my answer would be x plus 4 squared minus 13. Now with question B, it says sketch the graph of y equals x squared plus 8x plus 3. Show clearly the coordinates of any turning points and the y-intercept. Now let's find out first the y-intercept. Now if it intercepts the y-axis, x would equal 0. So when x equals 0, you have y equals 0 squared plus 8 times 0 plus 3. So y equals 3. So it should cross somewhere like that. Now we know that a general quadratic, especially when it's positive, x squared, is going to look like that. Now we need to find out the turning point, where it starts to curve. We need to use the completing the square. So when I write y equals x squared plus 8x plus 3, I can write it like this format up above. So I can write it like y equals x plus 4 squared minus 13. Now I need to find the smallest value that y could take. Now the smallest value we would have to look at here. What's the smallest value something squared could be? Now the smallest value something squared could be is 0. So we have to look at when x plus 4 equals 0, what would x be? Well, x would be minus 4. So now we need to find our y. Now if this squared is 0, y would equal minus 13. So my turning point would be at minus 4 minus 13. So it would actually be somewhere here. So my graph would look something like this, with the minus 4 and minus 13 there, and you showing that it crosses the y-intercept at 3.